Hi everybody, welcome back. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. So in our lecture series of electric circuit analysis, previously we have discussed about the various concepts of electric circuit analysis. We have seen what are the elementary concepts, definitions for voltage, current and resistance. What do you mean by Ohm's law? What do you mean by Kirchhoff's law? And what do you mean by Kirchhoff's current and voltage laws? With some few example problems. The next concept what we are going to discuss in our lecture series is going to be about the mesh and nodal analysis. This mesh and nodal analysis forms a very great concepts in our electric circuits, in the electric circuits calculations. So what are the topics we are going to discuss today's class is KCL or KVL. We have to have a small recap. What is mesh analysis? Some problems related to mesh analysis and nodal analysis, and some problems relating to nodal analysis. Come, let's have a small recap of Kirchhoff's voltage law. As we all know, what is Kirchhoff's voltage law? The algebraic sum of the voltages around a loop is equal to zero, or the amount of potential rise is equal to potential drop, or rise minus drop equal to zero. So this is what the definition for Kirchhoff's voltage law, or drop minus rise is equal to zero. So with this small definition, we will just move into the forming a loop or mesh for a given circuit. So we have discussed the same example in the previous video. We have a source of voltage Vs and the resistance R1, current passing through resistance R1 is I1, current passing through resistance R2 is I2. We write an expression for this as V is equal to I1 R1 plus I2 R2. As in current variables, two different sources, positive side and negative sides for the resistance plus minus I1 R1 plus minus I2 R2. So starting at node A and the first voltage drop I1 R1, second voltage drop is taken as I2 R2, that is I1 R1 plus I2 R2, and the voltage rise is taken as Vs minus Vs is equal to 0. So as per Kirchhoff's voltage law, we form a mesh equation that is I1 R1 plus I2 R2 minus Vs is equal to 0. So this is explained with an example circuit problem over here. So what does this circuit consist of? It consists of three loops. Loop 1 having an voltage source of 100 volt with resistance of 8, 12 and 8. Loop 2 we have no voltage source. So 12, 6, 12, 6 ohm resistances. And loop 3 we have 4, 6, 4 and 12 ohm resistances. Writing an KVL for loop 1. We are taking three loops over here. Loop 1 is having 100 volt. So potential rise 100 equal to potential drops 8 I1 plus 12 I1 minus I2 plus 8 into I1. So we get an expression 100 is equal to the total of 28 I1 minus 12 into I2. Writing the expression for loop 2, 0 equal to 12 into I2 minus I1 plus 6 I2 plus 12 into I2 minus I3 plus 6 I2. So wherever the resistance comes in between two loops, we are going to consider both the loop currents. So that comes the expression I2 minus I1 or I2 minus I3, etc. The second expression becomes 0 is equal to minus 12 I1 plus 36 I2 minus 12 I3. Writing KVL for loop 3, 0 is equal to minus 12 I2 plus 36 I3 is the third expression. Solving these three methods using a matrix formula. So we convert the three equations into a matrix. 28 minus 12, 0, minus 12, 36, minus 12, 0, minus 12, 36, I1, I2, I3, which is equal to 100, 0, 0. So using the Cramer's law in in the analysis, we can solve this and find out the values of I1, I2, and I3 respectively. A similar mesh analysis problem is shown over here. Here also we can have three equations, that is three loops. So how many number of equations is decided by how many number of loops. So here we can take three closed paths, that is three loops. So three expressions. So loop 1, there is an voltage source 50 is equal to 10 into I1 minus 5 into I1 minus I2. I1 minus I2 and 3 into I1 minus I3, we have one expression. Loop 2, we have an expression. Loop 3, we have an expression. So adding all these things, we get some values of the current values. So with the expressions, what we get is 50 is equal to 18 I1 minus 5 I2 minus 3 I3. 10 is equal to 5 I1 plus 8 I2 minus I3. 5 is equal to 3 I1 minus I2 plus 4 I3. Making this as an matrix, we get delta is equal to, we get some value. Delta I1 the matrix form delta I1 divided by del I2 is equal to delta I2 by del I3 is equal to delta I3 by L. So with this, we get the expression for the Kirchhoff's voltage law. What is Kirchhoff's current law? So Kirchhoff's current law, as a recap, we see current entering a circuit is equal to current leaving. The sum of the current at a junction point is equal to 0. Basic of Kirchhoff's current law, we go for nodal analysis where we form the node equations. Node equation are the two node points where we select V1 as a node 1, V2 as a node 2 in the above given circuit as an example. So 5 is equal to V1 minus V3 by 10, V1 minus V2 by 3. So V3 is nothing but the 5 amps. So when we just change the voltage source to current source, we get two expressions for KCL using nodal analysis. Solving the two expressions, we get the answer for the circuit. So similarly, you take these two problems as an example, and we can solve using the problems of the mesh analysis and nodal analysis. So as a recap, in this video, we have discussed about the basic concepts of mesh and nodal analysis, forming the equations using loops and number of nodes. Thank you for watching. We'll meet in the next video.